Have you ever wondered how helicopters defy gravity and soar through the sky? Today we'll look at these incredible machines that not only ascend to great heights but also have the unique ability to fly forward, backward, and side to side. This versatility comes from their complex mechanisms, setting them apart from other aircraft. Ready to uncover the fascinating science behind how helicopters fly? Buckle up, and let's delve into the world of rotating wings. Helicopters, like all objects in flight, rely on the principles of physics to stay airborne. These principles come to life in the form of four forces acting on the helicopter: lift, weight, thrust, and drag. Let's start with lift, the force that opposes the weight of the helicopter. The main rotor blades on top of the helicopter generate lift. As these blades spin, they slice through the air, creating a pressure difference. The lower pressure above the rotor blade and higher pressure beneath it results in an upward force: lift. This is what enables our helicopter to defy gravity and take to the skies. Weight is the downward force exerted by the mass of the helicopter due to gravity. It constantly opposes lift, and for a helicopter to rise, the lift must exceed the weight. Next, we have thrust, the force that propels the helicopter forward. In a helicopter, the angle of the rotor blades can be adjusted or pitched to direct the lift force partially forward, creating thrust. Finally, we have drag, the resistance encountered by the helicopter as it moves through the air. Like weight, drag is a force that the helicopter must overcome. It does this by generating enough thrust to counteract the drag. By manipulating these forces, a helicopter can hover, ascend, or descend. This delicate balance between lift, weight, thrust, and drag is what makes helicopter flight possible. Now that we understand the forces at play, let's explore how a helicopter's engine powers this symphony of physics. A helicopter's engine is the beating heart that powers its flight. This mechanical marvel is designed to convert fuel into the mechanical power that enables the helicopter to defy gravity and take to the skies. The engine's power is harnessed and transmitted to the main rotor and tail rotor through a complex system of gears. The main rotor is the large propeller-like structure that you see on top of the helicopter. As the engine revs up, the main rotor spins, creating a downward thrust of air. This action, in turn, produces an equal and opposite reaction, known as lift, propelling the helicopter upwards. But the power of the main rotor doesn't just provide lift, it also furnishes forward thrust when the pilot changes the angle of the rotor blades. This is how a helicopter moves forward. Meanwhile, the tail rotor plays a critical role in maintaining the helicopter's balance. When the main rotor spins, it generates a force known as torque, which tries to spin the helicopter in the opposite direction. The tail rotor counters this torque, keeping the helicopter stable and in control. These systems, powered by the engine, work together to create the unique flight capabilities of a helicopter. Each rotor, each gear, each component plays a critical role in the intricate ballet of helicopter flight. With the engine and rotors working in harmony, a helicopter can hover in the sky. But how does it move in different directions? Controlling a helicopter's movement in the air is an intricate dance of physics and engineering. To envision this, let's think about the main rotor blades of a helicopter. They don't just mindlessly spin. The angle at which they cut through the air, known as the angle of attack, can be subtly altered. This change in angle can cause the helicopter to move forward, backward, or even sideways. Imagine the blades as the hands of a skilled pianist, each change in the angle of attack, a different note, crafting the melody of the helicopter's flight path. It's this delicate adjustment that allows the helicopter to hover in place, move in any direction, or spin on its axis. Now, how does a pilot control this? Enter the collective and cyclic controls. The collective is like the throttle in your car. It changes the lift of the rotor blades, allowing the helicopter to ascend or descend. The cyclic, on the other hand, is a stick that changes the tilt of the rotor disc. This adjustment allows the helicopter to move forward, backward, or sideways. So you see, it's not just about spinning blades and a roaring engine, it's about the intricate dance of controls and physics. It's about the harmony between man and machine, each responding to the other's cues to craft a seamless flight. So there you have it. The magic of helicopter flight all boils down to physics, engineering, and a little bit of pilot skill. Helicopter flight might seem like magic, but it's really all about science and technology. From the delicate balance of forces to the pivotal role of the engine and rotors and the control techniques pilots use. Next time you see a helicopter hovering in the sky, you'll know exactly what's going on behind the scenes. Until then, keep your curiosity high and your learning higher.